The VPNs, when we say VPN, IPsec VPN, authentication method is of two types. One is PSK, pre-shared key. The other one is PKI, public key infrastructure. What does this mean?
Today we will discuss about what is topic.
You guess. What's your guess? You guess what will be the topic today?
I don't know. I follow you.
No, from the way that I started, what is your guess? What is that we did in the previous class?
Yeah. Cloud.
Okay, in both we used pre-shared key, isn't it? Today we are learning PKI so that we can use PKI instead of pre-shared key. Right? Now what is this PKI? Public key infrastructure. Public key, meaning instead of giving the pre-shared key beforehand to the routers, we are going to use certificates. To authenticate, we are going to provide certificate. I'll provide my certificate. You check whether the certificate is real, genuine, and you accept me. Likewise, you provide your certificate to me, I check whether it is genuine, and I accept you. So instead of sharing the password, we are going to exchange the certificate. What is the certificate made up of? It is made up of public key, which means there is another key, private key. If there is a public key, then there is another key also called what? Private key. So before we get into this PKI, let's talk about this public key and private key. A pair of keys, key pair. Now, what is this pair doing? We use public key and private key so that no one else other than the two parties will be able to decrypt the data. We got pair of keys so that we can guarantee that no one will be able to open the packet except the genuine peer members. How is that possible? You see, when I lock my door with my key, only I can come and open it because I only have the key. No one else have this key. This is more secure than what I said now. Using two keys more secure. What is that? I have a pair of key, assume for my house, I have a pair of key which will be for two different purposes. One, to lock. Another one, to open. So you cannot use one single key to both locking and unlocking. Locking, anyone can do this lock, but unlocking can be done only by the owner. So what I do, I tell all my house servants to lock and go before they go. They lock and go, but they themselves cannot unlock. They cannot unlock, they can only lock the door. Only I can lock unlock the door because I have that private key. Only a private key can open the lock which is locked by the public key. Public key will be available for everyone, whoever wants it. If someone wants my public key, I'll give them the public key. But private key, I will never give to anyone. So whoever wants to lock my door, they are free to lock. No problem. That's safe for me also. Someone is locking because it is kept open. I forgot to lock. Someone is locking for me. I'm very happy for that. I allow the public to lock my door, but I never give permission to anyone to unlock my door. Unlocking is only with me, the public key. Sorry, the private key. Only the key that is there with me can unlock the door. Fine. These two keys will be generated by the site-to-site routers. In both sites, both the routers need to generate now a pair of keys using an algorithm called RSA. Using this algorithm, a pair of keys is going to be generated by the routers that are in two different sites. So let us draw that site. Site 1 router here, site 2 router here. Both generate key. Let me draw the key of site 2, the purple key. And the blue side key blue key. And this is private, and this is public. Public, private. Private key, we keep it very safe. We don't share to anyone. We don't share to anyone. We use it only for unlocking. Now, this blue public key is what I'll use. I'll give to this guy. This blue public key is what site 2 will give to site 1. Why, you know? Please understand, this is the main story. This public key of this purple color will be used by site 1 to encrypt. Now the encrypted data is going to the other side, which can be decrypted only by this key. Whatever is encrypted by the public key can be decrypted only by the private key of that same pair, same combination. You see? Likewise, if site 2 wants to send the data to site 1, site 2 will put the data, encrypt with the public key and send the data to site 1. No one can open it, only site 1 who has got the private key can open it. Is that understood?
Yes, but communication about yeah, between site one and site two. How do site one or site two know or will send the public key? Is by email or by what?
I'm coming to the story. Give me some
Okay,
time. I'm just explaining the usage, how this private key and public key is used to secure your data.
okay, okay.
Now, the key part is over. We understood the key part. But you see, the public key of both the sites are now with the opposite parties. Site 1 public key is with site 2 now. Site 2 public key is with site 1 now. How will site 1 and site 2 know that this is genuine key? How will site 2 know that this is a genuine key from site 1? I can encrypt and send the data. What if this is given by attacker and site 2 encrypts with the attacker's public key and send the data, and attacker opens it with his private key? What if it is sent by attacker? So there is need for something more. What is that? There is a server in the internet, or you can also configure a server in the cloud called a CA server, Certification Authority Server. A certification authority server, I draw a building because it's a certification authority. So before sending these keys, to the other side, first of all, they need to get attested by this certification authority. Before this, both sides send their key, they need to get signature from the certification authority. Certification authority is like GoDaddy. GoDaddy, you know GoDaddy. Verizon. They all do digital signature. When you start a company, this is what actually happens. You need to provide your all details, your location, your office address, your ID proof, age proof. Then there is one certification authority for every country. They verify it, they sign it. Now with that with that certificate, you can start your business. When you do your business, everyone will accept you because you got the certificate signed by the certification authority. They may not trust us, but they will trust our certificate. That the certificate with the signature of the certification authority. So that is how we buy now in online. We don't know any vendor. But vendor knows, sorry, but Amazon knows both the vendor and Amazon knows us. Because we have given our phone number, we might have got OTP to prove that we are genuine. So Amazon knows us. Likewise, Amazon knows the vendor, the seller. Now we see Amazon, the certification authority is the Amazon here for us in our example here. Because Amazon says this is a product, nice product sold by so and so, we buy it. We pay or we do pay on delivery and we purchase. We both the party seller and the buyer trust each other because of Amazon. Otherwise, we don't trust. Seller is not ready to send the goods if Amazon is not in the middle. They will not agree for cash on delivery. Because Amazon is there, they trust. They do cash on delivery. So now, site 1 needs to send his public key, to CA. And CA will verify. In that, in the public key, there will be serial number of this router, and there will be a key, and there will be a router ID or domain name. All this will be there in the public key. Along with the public key, RSA key, the key ID, serial number, everything will be there. So certification authority verifies. It verifies and it puts a signature. This is the signature. Using HTTP or HTTPS, you can download the signed certificate. This is your public key with CS signature now. Likewise, this also has got the signed CS signature for the public key. Now both have got CS signature on it. Site 1 knows how the CS signature will look like. It knows. Site 1 has seen the signature. It will have the download of the signature. Site 2 will have the signature downloaded in its database. Now, Site 1 requests for a public key and Site 2 sends the public key. Likewise, Site 2 wants to send some data, so Site 2 requests for a public key. Site 1 sends the public key. Using this public key, it checks whether this public key is genuine by comparing the signature. Yes, it is matched. Because the signature is matched, Site 1 agrees to use this public key to encrypt the data that it wants to send. This data is now encrypted by this. And this encrypted data is now sent to the other side. Likewise, the data on the other side is encrypted by this public key and it is sent to the other side. And now only this private key can open it decrypted. It opens it and gets the data. See how secure it is. No one else can open this data. And what is this data, This data is the authentication values. This is like a password. All this happens in phase one. When the phase one is good, there is no problem in phase two encryption and decryption. This is for key encryption. This data is a key shared, not the email that you are sharing through VPN, not the file that you are sharing through VPN. That is phase two. That is transform set data. This is key. This is how the phase one tunnel is established. This is how the key exchange happens in phase one. So when the phase one is secured, there's no chance for phase two to become um, weaker. When phase one is strong, phase two is also strong. So there is no change in phase two when you use PKI. Instead of using pre-shared key, we are simply using PKI. This is what PKI, what I explained is what PKI. When you talk about PKI, it is not talking about phase two. It is talking about the authentication method in phase one. Yeah. So we don't have big changes in phase two. We will be having some changes in phase one. So I'll be doing this first. Now I'll be configuring a CA server. After which we will be having a certificate generated on all these sites. And the sites will send the certificate to the CA server. CA server will evaluate and put a signature, and the signed signature will be downloaded using HTTP or HTTPS. For this, you need to make this as a HTTP server, enable HTTP server, so it can be downloaded. The downloaded certificate will be used for phase one key exchange. Ask me a question, please.
Yes. So, so as you said, the TA server is there for the signature, right?
Yeah.
Okay. So the router will contact first the CA server
Yeah.
for authentication key exchange,
No, no.
right?
Routers will approach the CA server for the public key need to be attested. Public key need to be verified and signed. CA server job is just to verify who they say they are and put a signature. See, you might have got a signature on your certificate uh, when you were trying to go abroad somewhere. They might have asked you, your certificate need to be attested by so and so. Have you done such thing? The document attestation? No? You have done that?
Yeah.
Oh, same like that.
Okay. My question now is, okay, after router contact the we have the signature for the public key notification, and now both routers of site 1 and site 2, how do they will communicate?
Okay. No. No, they send it through internet. It is ISA KMP. It is UDP 500 packet. You don't need an email.
Yeah, how they send to another site? That's my question.
Site 1 will go and request site 2. Site 1 will say, hey, you are configured as my neighbor. Do you have anything to share with me? And site 2 says, oh, here is the public key. Take it, my public key.
By the tunnel.
Yeah, internal, the conversation. They do it automatically.
That is always my question, because about the PKI communication, so I didn't understand how the communication happens. So explaining me this step by step, it's very oh my god.
Okay, site 1 requests for certificate from site 2. Site 2 provides the certificate, using which site 1 is going to encrypt the key and send it to the other side. And site 2 can now decrypt and see the key and authenticate site 1. Likewise, site 2 requests for a public key of site 1. Site 1 sends the signed key. Using that key, it encrypts, site 2 encrypts its own key and send it to the other side. The other side decrypts it and finds the key. That's how they find themselves as genuine, and they move to second phase. Phase 2 is done because authentication is over. Key exchange is done, and the key will be valid for 24 hours. But the signature that is given by the CA will be valid for 1 year. You can also revoke it in the middle if you do not want to continue. You can revoke it. You can revoke it. So the signed certificate is what helps to authenticate each other. It is not a pre-shared key.
Okay. So suppose that the communication between the two sides by PKI, suppose that happens only via tunnel, right?
Yeah.
Okay. Suppose that we didn't have a CA server,
Hmm.
or it does not exist.
Hmm.
How can we use PKI?
Then you need to copy the public key, send to someone through email or through a thumb drive, a flash drive to the other side, or through cell phone, WhatsApp or message, something like that, and he will copy and paste it. But that is not the usual way. If you don't have a CS server, public CS server, create your own CS server on the cloud. You can do that.
But the PKI, for example, the PKI, how it does generate
See, keys are locally generated. It is not generated by CA anytime. These two keys are generated on the site routers.
You can create on.
Yeah, you have your own PKI. You are using CA only for signature. All right then. So what we need to do is we need to configure a router to be a CA server, and we need to take two routers as two site routers, and we need one internet router. So we need four routers in our topology now. One for CA server, so I can make a router to act as a CA server. A Cisco router can be configured as a CA server. And then we got an internet. And then we got two site routers. So totally four routers we need to do this lab. Yeah.
To have a lab, how many time we have to create that?
You mean how long it will take? Is that you mean?
Yes, yes.
Uh,
Because